Hi everybody, we're in the studio where a cut-in's about to happen. Stand by.
Good afternoon everyone, I'm Claire Kelly, News Stories, bringing you the latest updates on the coronavirus every hour. Starting today, St. Louis City and St. Louis County are launching new web portals on their website.
I'm sharing studio space with Claire Kellett. She'll be off the air in just a moment, and we'll get started.
Also today, we are learning the University of Missouri announced it will
Going to get started in just a little bit.
this fall. Remote learning, however, will
Welcome,
continue
welcome.
this summer. And in national headlines this afternoon, another 4.4
Welcome,
million
welcome.
American workers filed for unemployment last week. 26 million workers have filed for benefits in the last 5 weeks. We will have more updates on the coronavirus coming up for you in just an hour. But for now, we send you to the top.
All right. Hey everybody, I'm Meteorologist Meghan Danahey. We just had to share studio space with my co-anchor Claire Kellett. Hey Claire!
Hi guys, have fun!
Thank you. So we're here. We're going to do Let's Weather Together. Today we're going to talk about hurricanes. Yeah, that'd be awesome. Thanks, Claire. Hi, Stephanie Sean, 10-year-old from Troy, back. Very good. Hi, David Curry. How are you doing? So we're going to let some people gather in here. Today we're going to talk about hurricanes, and I want to do it a little bit differently. You know, each one of these has been a learning experience for me as well, and I realize that some of the videos have gone a little bit longer. So what I want to do today is take about 15-20 minutes to get through the basics of hurricanes. So for the younger kiddos and for those of you that need to pop in and pop back out, you don't have to stay on as long. Hey, Marcus. So for 15-20 minutes, we're going to talk about the very basics of hurricanes. Then, for those of you who can stay a little bit longer or who are interested in some of the other topics, we'll get into things like what steers hurricanes, how we track them, what is storm surge. So we'll get into some of those more specifics for those of you that can hang on a little bit longer. Again, the first 15-20 minutes, I'd really like to talk about the basics. So how hurricanes form, where they form, how they're named, all those kinds of questions that folks have when it comes to tropical weather and hurricanes. As far as my experience with hurricanes, I did work for a couple of years in Fort Myers, Florida, and I went through the landfall of Hurricane Wilma, which was a major hurricane when it came on shore in Southwest Florida back in 2005. So that was kind of an intense experience for me. So I love tropical weather. I think it's a very fascinating topic, and we've had a lot of questions about it since we got these things started. So want to talk to you a little bit about hurricanes today. We'll get through the basics. Hi, Brenda, your grandkids, Shane, Shania, and Sheldon are watching. Welcome, welcome. And again, welcome everybody. Thanks for joining me for Let's Weather Together. Of course, I'm meteorologist Meghan Danahey, a meteorologist at KMOV Channel 4 in St. Louis. And today I thought we'd talk a little bit about hurricanes. So I want to go ahead and start in on some of that. Let's switch. Hi, Amy Kerber. Good to see you, buddy. Hope you're doing all right. So let's get started here with that is a picture of Hurricane Katrina. Anybody recognize it? Hurricane Katrina. We're going to spend the first 15-20 minutes talking about basics here. We're going to get through some hurricane basics, how they form, where they form, what are the different names, who names them. And then for those of you that want to bow out after that, that's great. 15-20 minutes. After that, if you could stick along a little bit longer, we'll talk about tracking. We'll talk about what steers hurricanes and storm surge. But let's talk about hurricanes. And that is a typical satellite image of what a hurricane looks like. Hi, Mandy from Steelville. Ian from Labadee, good to see you. This is a typical image from space, and this is Hurricane Katrina. Actually, when Hurricane Katrina was at her strongest on August 28th in 2005. Katrina was 400 miles wide when it made landfall in Louisiana. You can see, okay, it was 400 miles wide at landfall, but look at its peak strength here in August of 2005. It was almost as big as the Gulf of Mexico. So hurricanes are huge storms, and they're basically just giant areas of low pressure. The biggest hurricane, one of the biggest hurricanes, 600 miles wide. That's the distance from Oklahoma City to Nashville. So hurricanes are huge storms. They are multiple states wide in most cases, huge storms. They usually form, our hurricanes, the ones that we have to worry about, come from the Atlantic Ocean, the Caribbean, the Gulf of Mexico. Our hurricane season, the Atlantic hurricane season, is from June 1st to November 3rd. So we're not quite into hurricane season, although in some years you can get a hurricane a little bit earlier, and you can certainly get one a little bit later. We've had a hurricane as late as New Year's Eve. So where do they form? Remember that hurricanes love warm water. So hurricanes form in those warm waters a little bit closer to the equator, where the water temperature is 80 degrees or higher. They really like that warm water. So that's generally where they form. Now, typically they'll move away from those areas. Hi, James. They'll move into the cooler waters and into the northern latitudes, but they start very close to the equator. And in the Atlantic Ocean, this is typically how they move. They move across the ocean from east to west. Hi, Carol. She says her first hurricane was Audrey in 1957. I think that was the year. I'd have to look it up. Hi, Jake from Godfrey. So in the Atlantic Ocean, they're called hurricanes, and they generally move from east to west. But I'm sure you've heard that hurricanes have different names. So what are they called in other parts of the world? Well, you get hurricanes in the Indian Ocean. They're just not called hurricanes there. They call them cyclones. And notice that the movement is still east to west, and then they start to move into those pole latitudes, those pole locations. So you get the formation near the equator in the Indian Ocean, and then they move east to west and drift away from the equator. But in the Indian Ocean, they're called cyclones. What about the Pacific? At least on the western side of the Pacific, over toward the Philippines, over toward Japan and Australia, they're known as typhoons. They're the exact same storms, they just have different names in different parts of the world and in the different oceans. The eastern part of the Pacific Ocean there, you can see the west coast of the United States, you can see Hawaii, those are also called hurricanes. So we have hurricanes in the eastern Pacific, and we have hurricanes in the Atlantic. You have hurricanes in every ocean of the world. They're just called something a little bit different in different locations. Hey there, Nick. So why doesn't California get hit by hurricanes? We have hurricanes over there often, but they move away from the United States. Generally, let's see if I can do this here. Generally, they form in these locations, in this warmer water. This is the ocean current in this area. If you've ever been to California and if you've ever dipped your toe into the ocean there, it's cold. That's some cold water that moves from north to south down the west coast of the United States, because the current in the Pacific Ocean looks like this, and the warmer water moves away from the United States. So generally you get some development here of hurricanes. Sometimes they can circle back down into here and then hit Mexico, but a lot of times your hurricanes that form in this zone drift back off to the west, and these are the hurricanes that would impact Hawaii. Let's go back to the Atlantic Ocean. Similar current here. Similar current here. Stephanie, I see your question about tornadoes, and I will answer that. Yes, you can get tornadoes when a hurricane is making landfall. You don't get tornadoes generally when they're out over the ocean, but when the hurricanes make landfall, actually there's a certain quadrant. It's actually the northeast quadrant of the hurricane where you can get very quick, brief tornadoes. The current is very similar in the Atlantic Ocean. Now, if you've ever been over to Florida or the Bahamas or on the East Coast and dip your toe into the water, you'll notice that that water is much warmer. Obviously, the beaches on the Gulf of Mexico, nice warm water back through the Caribbean. This is called the Gulf Stream right here. This is the ocean current that runs up the east coast of the United States. So this is all warm water on this part of the Atlantic Ocean, and this is where our hurricanes generally come from. Now, sometimes you can get development of hurricanes a little closer to the United States. So sometimes you can see them develop there in the Caribbean. Sometimes they develop right there in the Gulf of Mexico and move on shore. That a lot of times happens later in hurricane season, when we get toward the end of hurricane season. You get a lot of Caribbean development and Gulf development in October. And the reason why? Because of nice warm water. This is generally where they form. The hurricanes that the United States has to worry about most of the time form there close to the equator. We just talked about that, where the water's nice and warm. A lot of times you have a tropical wave or a disturbance, an area of thunderstorms that will move off of Africa, and it will drift this way, and it has all of that warm ocean to get stronger and to grow. So you have formation out in this region, and if the conditions are right, you can have big hurricanes that form out there in the middle of the Atlantic and then come over here and impact places like the Leeward Islands, as well as Puerto Rico, Dominican Republic, the Bahamas, and eventually into the United States. So that's pretty much where our hurricanes form. Now let's talk a little bit about more what those hurricanes need. I'm going to switch back to here. That's generally where they form. I've got an illustration back here behind me to talk a little bit more about what they need. Hurricanes need some pretty specific things, just like tornadoes. When we talked about tornadoes, we talked about the ingredients that had to be there. Everything had to come together just right to get your tornado to touch down. Well, same thing with the hurricanes. We actually have to have very specific things. So let me spin this around so the text is not backwards. All right. So this is my chicken scratch of a hurricane. There it is. That's pretty much what a hurricane looks like. Now, what do they need? We said that they need to start with a tropical wave or an area of low pressure. The hurricane itself is a giant area of low pressure. It has a whole lot of storms wrapping around it. So ingredient 1, tropical wave or disturbance. Ingredient 2, warm ocean water. Warm ocean water. We're talking 79, 80 degrees or above. So you get that warm ocean water, you get that area of low pressure. The next thing that's going on is winds flowing inward at the surface. As your winds flow inward at the surface, and you can see all those red arrows there, as your winds flow together at the surface, it forces air to rise. Remember, we need that rising air for thunderstorms and clouds. We talked about that in previous videos. So winds flowing inward at the surface, rising, rising, rising. All that warm ocean water, what does it give us? Well, it gives us, and this is a highly technical term, gobs of humid air rising. You get a lot of humidity, a lot of rising air. That gives us a lot of condensation, a lot of clouds, rain, and even a few thunderstorms tucked in there. So you need warm ocean water, winds flowing in at the surface, gobs of humid air rising, and at the top, winds actually flow outward. It's kind of a weird looking top, but that's the best I can do as an artist. So your winds are flowing outward at the top. What does that do? It helps to pull more air up from the surface. So you have two things helping air to rise. You have winds flowing inward at the surface and rising. You have winds flowing outward at the top, which leaves a void for more air to rise. Now, one of the main ingredients we talked about in severe weather was wind shear. You had to have wind shear to get severe storms. Guess what? Hurricanes hate wind shear. It's the opposite for hurricanes. You need very light steering winds, very light winds on the outside of a hurricane. If you have too much wind shear, if you have, remember we talked about it, winds increasing with speed as you go up in the atmosphere, if you get faster and faster winds as you go higher, it'll tear the hurricane apart. So wind shear is bad for hurricanes. You need warm ocean water, you need winds flowing inward at the surface, gobs of humid air rising, winds flowing outward at the top, and no wind shear. And you get a machine. And some of the things that are here, you have rain bands, you have, this would be an eye wall. You know, when we look at hurricanes from space, they look like big donuts with a hole in the middle. That would be the eye. So you have rain bands, eye wall. The eye wall is the most powerful part of the hurricane. So those are the ingredients that you need for hurricanes. Let's go back over to graphics. How are we doing so far? Hello, Raymond. I'm from Missouri and currently in Florida. I hope the weather's nice in Florida. Let me sit back down here. All right, so we'll get back to the graphics that we have going on and we'll continue our discussion. Hurricane basics. So hurricanes have names, right? Like Katrina. Who names them? The World Meteorological Organization names hurricanes. And there are 6 different lists that alternate each year. So you have 6 different name lists, and that's just for the Atlantic Ocean. There are also names for our Pacific Ocean hurricanes, as well as the hurricanes in different parts of the world. If significant damage occurs, then that name is retired. It's kind of like retiring an athlete's jersey. That name will never be used again. Katrina, for example, will never be used again. And likely Dorian from last year will never be used again. Some people that are pretty important are hurricane hunters, and I want to talk about them in just a minute, but I also want to show you the hurricane names. Here's an example. I know you can't read those names very well, but this is the list. We have 6 different lists. Here's 2020. The first named storm will be Arthur. And then you have Bertha, Cristobal, Dolly, Edward, Faye, Gonzalo, Hannah, Isaias, Josephine, Kyle, Laura, Marco, Nana, and so on. And if any of these misbehave, if significant damage is caused there, then you're going to have that name retired. So those are the lists of names. Let's get back to hurricane hunters because they are really awesome. Okay, who are hurricane hunters? They are scientists that work for NOAA, the National Oceanic and Atmospheric Administration, the government. And they will take airplanes and make 4 to 6 passes through hurricanes. One mission can be 10 hours long. They have instruments. Remember when we talked about the weather balloons that went up into the atmosphere, and those instruments were measuring temperature, pressure, wind speed? That was a radio sonde, a weather balloon that went up into the atmosphere. Well, the instruments that fall from these planes are called drop sondes because they drop through the atmosphere. They're released from about 42,000 feet in the atmosphere, and they drop through the hurricane, and they're measuring temperature, pressure, and wind. So the drop sonde data is very important because it actually tells us the strength and helps us with forecasting. Drop sondes, hurricane hunters, very important. In fact, I've got this little video that I'm going to play, if you can see it here. But this is an example of a hurricane hunting mission. See how they crisscross the storm. Crisscross, crisscross, flying right through the most intense parts of the storm, the eye wall through the eye. And then they have those drop sondes. You'll see one come out of the back of this plane. There's a little parachute attached to it. There it goes. And you can see that that instrument at the bottom is collecting data. It's going to be collecting temperature, pressure data. They'll release drop sondes all through that hurricane, and then they will head back to base. And that data that we get is very important. You know, we talked a little bit about tornadoes and how you had the enhanced Fujita scale. It was a damage-based scale. You have to go back and look at the damage after the tornado to determine the strength. Well, it's different in hurricanes. Hurricanes, we have a Saffir-Simpson scale, and it's actual measured wind speed. Those drop sondes tell us what the winds are, and we can give that hurricane what we call a category. And there's a look at the categories. The Saffir-Simpson scale, when we say, hey, there's a Category 3 hurricane out there in the Atlantic Ocean, you're talking about a hurricane that has winds 111 to 129 miles per hour. So the Saffir-Simpson scale is an actual wind-based scale where we have those measured wind speeds. Your strongest hurricanes are Category 5. Katrina at one point was a Category 5. Hurricane Wilma that moved into Florida was also a Category 5 at one point in time. But the winds are just part of the storm. We have storm surge. The water is another issue that can cause problems. So that's kind of the basics on hurricanes, where they form, the different names that they have, and how big they can be. Remember, we talked about it looking like a donut. I'll go back to the beginning here. So if you have to check out, that's pretty much the basics. If you want to stick around with me, I've got some cool information on how we determine which way they're moving. Hey, Meg, haven't seen you in a while. Good to see you. Super interesting. Thank you. Stephanie, there is actually a quiz on this that I can put up if you want to take it. Not a problem. Again, here is Hurricane Katrina, and I just want to go back because we said it looks like a giant donut from space, and it does. It really does. So this right in here is your eye, and sometimes in the eye it can be completely calm. The eye can vary in size. It can be 20 miles wide. It can be 40 miles wide. There was a hurricane that hit Southwest Florida actually down in here, Port Charlotte, Hurricane Charlie. And it had a 4-mile wide eye. It was a teeny tiny eye. So the eye can vary in size, and then right around the eye wall, that's where the most powerful winds are. And then all of this that you see spiraling into the hurricane, that's all rain bands. These are individual rain showers and thunderstorms. You don't really see a lot of lightning in hurricanes, but you do see a whole lot of rain, right? They're made with all that warm water, a ton of humidity, and as they move closer to land, they bring all of that with them. So, hi, do you know how big one of the drop instruments are? I actually don't know how big they are. I would have to look that up. But there's a quick review on that. They're giant areas of low pressure. We talked about that. Sometimes they can be 600 miles wide. They're huge. And again, our hurricane season is June 1 through November 30th. You can have, just like tornadoes in different times of year, you can have hurricanes different times of the year as well. This water out here is nice and warm, and that's generally where our hurricanes form. So if you have to check out with the kiddos, I really appreciate you joining in for those hurricane basics. If they have any questions, send them along. You're welcome to email me or to put them on Facebook, and I'll go back through and answer. Angie, what kind of degree education is required to become a scientist who flies the 10-hour missions? You know, that's a really interesting question. They are, I believe they're also Air Force. I'd have to look more into that and get back with you. But you have a combination. You actually have pilots who are the crew of these aircraft, and then you have meteorologists. So you have a crew, a team, if you will, that's on this airplane that is helping to gather this data. So it's a good question, and I'll have to get more into it for sure. All right, so let's get more into the steering stuff because it's pretty interesting. So this is where we left off. Let's go here. They are Air Force, yes. Thank you, Nick. I don't have all the details about hurricane hunters. I can't imagine going on one of those flights. It must be bumpy as all get out. It must be kind of scary, I would think. A lot of turbulence around those hurricanes. Okay, so here's what stirs hurricanes. Why do some hurricanes hit the United States and some completely miss us? Well, it has to do with some features that we see. You've got something that's called the Bermuda high pressure or the Azores high pressure. Basically, this high pressure is a pretty permanent feature during hurricane season over the Atlantic Ocean. So this big H, sinking air. Hurricanes will not move into that high pressure, okay? That's a big blocking high. So hurricanes are going to go around that high pressure. So where hurricanes go are kind of a function of how strong is the Bermuda high. That's something that we watch all summer long and all during hurricane season because the strength of that high will determine where hurricanes go. Let's make it a weak high pressure, okay? So this is a weak high pressure. As soon as the hurricane makes it over to the west side of that high pressure, it's going to want to turn north. It's going to want to follow. The winds go around a high pressure clockwise. So here comes our hurricane. It's coming in below the high pressure. It's moving from east to west. As soon as there's a weakness in that ridge, it's going to turn and go north. So a weak high pressure usually turns the hurricane early. And it's in these situations where you have hurricanes that you may not even remember or you may not even hear about because they just stay out to sea and they affect fish and shipping channels. So these are the storms that recurve. Now here's Bermuda right there. So Bermuda can sometimes get hit by these, but this kind of storm is not going to do any damage over here. So what keeps them coming to the United States? Let's change the scenario. Let's make it a big, sprawling, strong high pressure. All right? So in this situation, what's the hurricane going to do? It's not going into the high. It's going to follow those winds, right? It's going to keep moving west. So if you've got a big, sprawling high pressure out there, your hurricane's moving west, it could impact the Leeward Islands. You know, here you've got Puerto Rico, you've got Cuba, you have Jamaica, Dominican Republic, and Haiti, of course, the Bahamas. So here comes this hurricane now moving west, 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 west. Sometimes they can continue moving west all the way in here and then start the recurve into the Gulf of Mexico. If you got a strong enough high pressure, they'll do that. But this is how they curve when you have a big, strong high pressure. They move more into the Caribbean or to the very far western Atlantic there, and then they'll start their curve a little bit too late for the United States, right? We'd rather they curve back out at sea because then they don't do damage. But a big, sprawling high pressure can cause landfalling hurricanes in the United States because it keeps the hurricane moving west longer before it makes that turn. All right, so that's one of the steering mechanisms. Once the hurricanes are getting closer to land, there are other things that help to steer them. They're also moving into higher latitudes, so they're moving away from the equator, they're moving into cooler water, and now they're running into something called the mid-latitude jet stream. Jet stream, this jet stream right here, helps to steer all of our storms that move from west to east across the United States. So a lot of times you'll get an area of low pressure. Today, for example, in St. Louis, we have an area of low pressure that is actually going to be sliding just this way off to the north and east, and it's bringing a bunch of rain. So this jet stream drives our weather systems, cold fronts, low pressure across the United States. So let's put a hurricane a little closer to the United States. Here's our hurricane. It's made that turn around the western fringe of our Bermuda high, all right? So now it's moving toward the United States. Where does this hurricane go? Does it go up into this jet stream? No. The jet stream is going to influence it just as much as the western edge of the Bermuda high. So in this situation with the big, and what we call this is a trough. Whoops, I moved the whole jet stream. What we call this, okay, stop doing that. Where am I? Here I am. This is a trough of low, this is a trough in the jet stream. So this hurricane is going to get picked up and moved out this way. So the mid-latitude jet stream can help protect the United States from getting hit as well if it's timed out where you happen to have a trough there. Let's look with the trough a little bit back into the central plains. So we're changing the situation now. So now we have our trough back over here, and we have our hurricane in the same spot. So where is this hurricane gonna go? This not picking up the jet stream just yet. So this one will actually continue to move inland before it makes that turn. So it gets picked up by the jet stream after it's already inland, and its remnants move back off to the north and east. So you've got steering flow from the Bermuda High, you have steering flow from mid-latitude jet streams and storm systems. Now watch this. Sometimes hurricanes get stuck. They move on average 10 to 20 miles an hour, so they move very slowly. That's slower than a school zone at the speed limit. They move pretty slow, 10 to 20 miles an hour, but sometimes they move slower than that. If you'll remember last year, Hurricane Dorian did all kinds of damage in the Bahamas because it sat there. It basically had no steering flow. Sometimes hurricanes get cut off. Sometimes, your Bermuda High is getting weaker, and that steering flow is moving off and away from the hurricane. Sometimes the jet stream isn't there to help yet either, and your hurricane's just sitting there. It has to wait for something to pick it up and move it. And underneath it, unfortunately, you're getting a lot of damage. So sometimes there's no steering flow. At one point, Dorian last year was stationary. It was not moving. And then when it was moving at 3 miles an hour. And that's why the Bahamas were so devastated underneath, because hours and hours and days of hurricane winds cause problems. So this graphic, that's a little bit about steering. I'm going to mess around with this graphic a little bit, and I'm going to change the view here. This is something that when we track hurricanes here at the station, we use, let's see, I need to move this down just a bit. Okay, there we go. So this is one of the graphics that we use at the station. The hurricane I think I'm going to use, if it didn't go away, is Irma. Yeah. So we don't have any current oh, it's not going to let me do the track. Rats. I ran into this problem yesterday. Let me see if I can find another test. Oh, there we go. Okay, the data loaded. So this graphic has multiple things on it. The first thing I have turned on is, you see all these lines here? I can actually track the hurricane hunters. You can actually turn that on and off. See the recon tracking here. So you can actually track these hurricane hunters. You can get the real-time data that they're getting through this graphic. One of the ways that we forecast hurricanes is something called a spaghetti plot. Why do you think it's called a spaghetti plot? These are computer models because it looks like biscotti, right? This is what would be an example of a spaghetti plot. Now, when hurricanes are way out to sea, the spaghetti plot can be pretty different. It can look like a big mess. But here, in this case, the hurricane was very close to land, and we had a pretty good idea of where it's going. But the spaghetti plots are basically different computer models that are trying to determine the path of the hurricane. And that is how we draw the cone of uncertainty. The cone is what you usually see on TV or the tropical track. Let me turn the spaghetti plot off. And let me turn the position off. No, locators. Oh, it's okay, they're fine. But so here's the cone. Right here, Irma was a Category 3. It moved over western Florida, and you can see out through time where that storm went. So we use recon data from hurricane hunters. We have to forecast how strong the Bermuda high is. We have to look at the mid-latitude jet stream and storms that are going on in the United States. We have to look at the spaghetti plots. All of that comes together on where the hurricane's going to go. And the experts on that are at the National Hurricane Center in Miami. Just like the Storm Prediction Center in Norman, we talked about that. Those are our tornado experts and our severe weather experts. We have hurricane experts that are down in Miami. One last thing I want to talk about, and that is storm surge. Storm surge is very interesting. There are two issues going with hurricanes that do damage. One is the wind, obviously. But the next thing that does damage is storm surge. So what is storm surge? Storm surge is ocean water that is moving inland into places it's not supposed to be. And it's the water and storm surge that can cause a lot of problems. One of the things we say to people who are evacuating or trying to protect themselves from hurricanes is you hide from the wind and you run from the water. So you put up hurricane shutters. If you're not in a flood zone, you put up hurricane shutters and you ride it out because you can hide from the wind. If you're in a flood zone or in a zone where storm surge may be a problem, then you have to leave, and here's why. So this is Katrina again. We're going back to that original image of Katrina. And remember, Katrina was sitting in the middle of the Gulf of Mexico as a Category 5 hurricane, the strongest hurricane you can have, and it is piling up water. Remember that the motion around low pressure is counterclockwise. So the air is spinning this way. The whole hurricane is spinning this way. So where do you think the water is piling up? What would cause storm surge? The air is spinning this way. Think about it for a minute. Where's the water piling up? Well, it could be piling up down here, close to the Yucatan. It could be piling up over here, and this is what I want to show you next, because this is what did all the damage in Katrina, mostly, was storm surge. You have water piling up on the eastern side of that hurricane that moved inland into places like Mississippi and Louisiana that caused the problem. So storm surge is water that's moving inland. Especially look at the shape of the Gulf of Mexico. This is a good example, and why Katrina was so devastating, because you've got this giant, this is all land, right? You've got Florida, you go around the southern Gulf Coast, here's Texas, here's Mexico. It's like a giant bathtub. There's nowhere for the water to go. So you put winds out here of 160 miles an hour, and it's going to pile up all this water. Waves and piled up water. And where does the water go? Even though Katrina weakened before it made landfall, it had already piled up Category 5 storm surge, and the water had nowhere to go. except inland. So storm surge is a problem, and it really depends on the shape of the coastline too, and also the depth of the coastline. So storm surge is a whole nother part of these hurricanes that can be very dangerous. You can also get that. Let me switch over to this, for example. Let me go over here. You could also have storm surge issues in this part of the United States. See here how it's shaped funny? Let's for example throw on, I can't see all my tools. I've got them minimized here. Let's throw on, whoops. I'm just going to do a little example in this part of the United States and show you how storm surge can be a problem too. And we've had several hurricanes that have done this. Let me use a different color. Let's use yellow. All right, so remember our water is piling up. So a hurricane sitting off of the east coast of Florida can do tremendous flooding up in eastern North Carolina as well as eastern South Carolina because the water is being piled up and sent into that coastline. See how the coastline sticks out like a sore thumb there? So if you have a hurricane tucked in here north of the Bahamas, you can get big storm surge on the east side that moves up into these areas here. And these areas may not even be impacted by wind, but they could be impacted by storm surge flooding. The key here is that hurricanes are huge and they impact a whole lot of people if they do move inland. Now, once they move inland, they're not very happy, right? They have to have that warm water. So once a hurricane moves inland, it begins to fall apart. But it takes several days for it to really fall apart. And remember how much moisture it's picked up off the ocean, and it brings all of that inland. So you get a ton of rain, you get thunderstorms sometimes once it moves inland, and some of those thunderstorms can twist and turn, and you can have very brief tornadoes as the hurricane makes landfall. So that was pretty much all I had planned to talk about. We talked about storm surge, hurricane hunters are a big deal. We talked about the wind scale, the Saffir-Simpson scale. Dropsons I think are really cool. Let me see if you guys have any. Hi there. Let me see if you guys have any questions. So much information to process. This is why forecasts don't go right. We're actually getting better with hurricane forecasting. The track forecasts have become really good. The intensity forecasts are not very good. It's difficult to determine how strong a hurricane will be once it moves inland. Something else I want to show you. Let's go back to the map really quick while we're talking about it, and let's get rid of this right here. This happens too sometimes. So let's say you've got this area of low pressure. Let's say you've had a little, and I don't have my hurricane icon, so we're pretending this is a hurricane. But let's say this thing has come and gone, and it goes out to sea. Let's say, and hurricane season sometimes can be busy, and you have another one right on its heels. Here comes another one up through the Bahamas in this same area. But guess what's happened? This first storm that came through has churned up all the water. And our good warm water, remember that 79, 80, 82 degree water that feeds these hurricanes? It's churned up at the surface. So you actually these storms will cool down the surface temperatures. So what you have a lot of times in a situation like this, if you have a hurricane that follows another one, that cooler water right underneath the hurricane will actually weaken it. It's called upwelling. It's another thing that's interesting about intensity forecasts and trying to determine how strong these things are going to be. Dennis was down in Florida when Hurricane George hit. Was driving the interstate during the storm. It wasn't fun. And Nick says being a hurricane hunter would be a very cool job. I absolutely think it would be a cool job. Karen, question for tornado. If I live in an apartment complex, where is the best place to go? A, my bathroom in the bathtub. B, in the middle floor of the parking garage in my SUV. C, in the first floor public restroom in the complex. All right. If I live in an apartment complex, well, it depends on what floor you're on. if you live on the first floor and if your bathroom doesn't have windows, that's a great place to be. I would probably not go into the parking garage. I think that wind will be able to get in there. And if you happen to be on a higher floor, the second floor, the third floor, then in a first floor public restroom would also be a very good place. So I'd say it depends on what floor you're on. If you're on the first floor, an interior bathroom, interior closet, and that means something that's in the middle of the apartment with no windows. But if you're on an upper floor, you always want to get to the lower floor. So make friends with their downstairs neighbor, or find a public bathroom, something like that. All right. Well, y'all, it was fun talking about hurricanes today. Any more hurricane questions before I wind things down? Storm surge always on the right side of the hurricane. Here's something that's interesting. Let me show you one more thing, just for fun. All right. So there was a hurricane that hit South Florida. I think it was Donna. I'm pretty sure it was Hurricane Donna. Now, we talked about storm surge. Let's put our storm surge back on. On this side of the hurricane, it's going this way, right? Let me make that bigger. Let me just start over. Scratch that. Do over. All right. So we've got winds going that way, and we have winds going that way. There was a hurricane in, I forget what year that was, but it was very interesting. As it moved inland into South Florida, there's actually onshore flow, right? Here's flow that's going onshore. And what is this flow doing? It's going offshore. So there is at the other side of the hurricane, and you can actually have water pulled out of riverbeds. In fact, that happened in Florida. As Donna moved inland, the flow that was going offshore on that side of the hurricane, the wind was so strong that it sucked water back out into the Gulf of Mexico. So you can have the opposite effect. You can have flooding from storm surge that's moving inland, and you can have water that's much lower than normal on the other side of the hurricane where the winds are moving offshore. So that's kind of interesting. I'm pretty sure it was Donna. Karen, do they think it will be a bad hurricane season this year? Is this something that they can even really predict? Actually, there are scientists that put out, let me see if I can find it. They release something early in the season. And a lot of it depends on global patterns. I don't know if you've heard of El Nino or La Nina, but those patterns can make it a worse season or a below average season. I'm trying to see if I can find, I can't remember. I think they said it was going to be slightly above average this year, and they were talking about an El Nino pattern. But yeah, there are scientists, and they do a tropical weather outlook where they say we think there's going to be so many named storms. Where is that information? I'm just going to have to go back. I mean, we can look at the Weather Channel and just see what they... Do they have it? No. That's not what I want. Why the 2020 Atlantic? Okay. So there's actually some pretty big scientists at Colorado State that put out these forecasts, and they update them several times during the year. But this was the one that came out in 2020, where they say, okay, average number of tropical storms each year is 12. This year, they're forecasting 16 tropical storms. Now, what's a tropical storm versus a hurricane? We didn't talk about that. Tropical storm is winds of 39 miles per hour to 73 miles per hour. So once you get 74 miles per hour, you have your Cat 1 hurricane. So tropical storms are also tropical systems. They're just not strong enough to be called a hurricane. So they're projecting 16. Hurricanes are projecting 8 when the average is about 6.5. And major hurricanes are Category 3, Category 4, Category 5, and they're expecting 4 of those. So it is expected to be above average, and mainly it's because of El Nino, which means less wind shear. Less wind shear. Remember, hurricanes don't like wind shear. So if there's not as much wind shear, they're going to be in a more favorable environment. And the warmer than average sea surface temperatures. Remember, we need that warm water. So El Nino gives us very warm water at the surface, and it means less wind shear. And so you can have hurricanes that grow a whole lot bigger in those environments. So it is expected to be a busy season. They'll update that as they go on. Let me go back to the Saffir-Simpson scale really quick. So you have a low pressure system that starts to develop into something more organized, and then they'll call it a tropical depression. When it's becoming a little more organized, that area of low pressure, it becomes a tropical depression. Then it becomes a tropical storm once you have sustained winds over 39 miles per hour. Once it's a tropical storm, that's when it gets its name. So you'll have Tropical Storm Aurora or whatever it is. So they get their name once it's a tropical storm and once you have winds over 39 miles per hour. And then once you have 74 mile per hour winds, you have a hurricane, and it will be Hurricane Aurora as a Category 1. As it strengthens, here's how you get your different categories. We talked about that just a little bit earlier. All right, I've taken enough of your time. So that is our little lesson on hurricanes. As always, if you have any questions, please drop them by. If you're even watching this later and you have questions, throw them in here. Or you can email me at Meghan, MEGHAN, .Danahey, DANAHEY, at KMOV.com. MEGHAN DANAHEY at KMOV.com, and I'd be happy to answer your questions there. I'm so glad you joined me today. Thanks so much for taking up an interest in tropical weather and hurricanes. I think it's a pretty fascinating topic, and we'll come up with something next week. I don't know. What should we talk about next week? Maybe send me your ideas too, and we'll come up with another lesson for next week. Maybe it's lightning. How does lightning form? I don't know. Put your thinking caps on and let me know. Meanwhile, stay safe, stay healthy, and I hope you have a fantastic weekend coming up.